Hey everybody, before we get started with today's topic on Galileo and Newton's laws, I want you to remember what we did last time when we talked about Kepler's laws. So here is your quick quiz for today. What we're going to be doing is you will see a Moodle quiz, and it will include all of the clicker questions in today's videos. So here is the first one about Kepler's laws. Write down your answer and make sure to do that quiz after you watch all the videos. Okay, so today's topic is why do planets orbit the sun? We talked about with Kepler's laws how planets orbit the sun, but today we want to talk about why. And we're going to keep on our theme of history here and start with talking about a man named Galileo. Last time we talked about Copernicus and Tycho and Kepler. Now we are going to get into a little bit more of the science, heading towards gravity and Newton. This is all going to tie together as we begin to talk about orbits. So, I don't really want red. Let me change my color here real quick. Let's do black. This is from section 2.4 of your OpenStax textbook, trying to understand orbits and gravity. And we are starting with Galileo. Hopefully, by the end here, you'll see how all this fits together with Kepler's laws and Newton's laws and gravity. So, who is Galileo? Galileo was an Italian who lived after Copernicus, about the same time as Kepler. He is, for our class here, the most important thing is he was the first to point a telescope at the sky. He was the first to use a telescope for astronomy. Okay, this was about 1609. Honestly, there could have been other people who pointed a telescope at the sky, but he wrote about it, and he wrote down some of the important things that he saw. Just a couple of those things before we get into Galileo's work in physics and how it's relevant to orbits. You can see here some pictures. The first is that he discovered that Jupiter had moons. So Galileo discovered what we now call, discoved. Sorry about that. Let me fix that. He discovered, go back to my pen. I'll get it right here. The Galilean moons of Jupiter. They weren't called that, of course, until he discovered them. He discovered Jupiter's 4 largest moons. Okay, now we know that Jupiter has a bunch of moons. There are about 60 something that are named, but we think that Jupiter may have really hundreds of moons. But the first 4, the biggest 4, you can actually see with the naked eye. Well, not the naked eye, see through a telescope. Nah, nobody saw them before he actually used a telescope. But we can see that today. If you ever get a chance to look through a small telescope when Jupiter is up in the sky, you can see those moons. The other cool thing here is that Galileo saw that Venus had phases. He saw the phases of Venus. And this fits right in with what we are talking about, the phases of the moon. So this down here, those are not pictures of the moon. Those are of the planet Venus. Turns out Venus can also get between the Earth and the sun, just like the moon can. And it's a little bit different because Venus doesn't go around the Earth, but we see different angles of sunlight on Venus, and it actually has phases. It's pretty cool, huh? Again, remember those phases are not because of shadows, but just because of the angle of the sunlight. And so Venus is just like the moon in that. All right, so Galileo, what we really want to focus on was Galileo's experiments that had to do with gravity and something called inertia. So Galileo, he was one of the first to actually do real experiments. This was really the beginning of science, and he actually experimented with moving objects. Before this, people would just kind of do thought experiments. But Galileo actually got various balls and rolled them down ramps and supposedly threw them off buildings. Uh, if the story about him dropping things from the Tower of Pisa is true. But he did real experiments and he developed the idea of inertia. And I suspect that this is a term that you have heard before, but not a term that most of us really remember what it means most of the time. But it's important for us as we're going to start thinking about gravity and orbits. So inertia is this idea that objects at rest tend to stay at rest, and objects in motion tend to stay in motion. You might have heard it phrased that way, but I'm going to say it this way. It's the tendency of objects to resist a change in their motion. So we have encountered this once before already, just in terms of a video that we watched. Does any of you remember the "Why Does the Earth Spin" video? It's not spinning because there's an active force pushing on it right now. It's spinning because it was made spinning, or it formed out of a spinning cloud of gas and dust. We'll talk about that later in the semester. It formed spinning and it kept spinning, and there's nothing to stop it, right? In space, there's no friction, there's no air resistance, and so it keeps going. It has a tendency to keep going, and that is what inertia is. Okay, so that's a little bit about our friend Galileo. I'm going to stop the video right here, and you will get to see um, Newton's laws in the next video.